Hello everyone, from Tony the Scar Ghost. I'm very happy to be here today with Kelly Peng from Kura. Hello Kelly.
Hello. Yeah.
We
Thanks,
will
Tony.
we will talk about amazing headset they're building since some years with a wide field of view. I'm lots of questions to ask you because I'm very curious about what you're doing, but let's start from the basics. So Kelly, for the people that still don't know who you are, can you introduce yourself and Kura?
Okay, yeah. So my name is Kelly Peng, and I'm a founder, CEO, CTO of Kura AR. So I'm a electrical, optical, software, or multidisciplinary engineer. I study at UC Berkeley, and before that at UIUC of electrical engineering, computer science, and also math. So before that, I was working on various projects and with either work or research or my personal project. So ranging from frequency modulated LiDAR and customized chip and UC Berkeley, or some holographic projects and research into that, collaborating with some large companies. Working on brain machine interface. Then I'm a co-founder of the Berkeley Cognitive Technology Group, working on brain machine interface, and also some personal recognizations like natural language processing stuff. And also other project was working on including like Hyperloop projects, one of those, and also like a nuclear like fusion reactor in my garage, and some relevant projects like spectrometers, other stuff. Yeah.
So many cool things. And so what is Kura and what is its backstory? So how it was born?
Yeah. So the background story of Kura, let me see. Where's the background story? So I started Kura when I was still in school in last year in school. And Kura's original name was not Kura. I started Kura originally as a brain machine interface company. So I was working on AR, but I saw the starting point is not optics, but like brain machine interface sensors. So that's why we were working on non-contact EEG sensors and EMG sensors for magnetic sensing, and also the algorithm to do the signal processing, classifications of different emotions. One thing I write was a like-dislike classifier. Based on like over 30 electrons of people's brainwave input. I tested initially on myself with over 80%, actually over 85% accuracy on the training data set. And we built an exhibition of that actually at San Francisco Exploratory over the course of 3 months, and demonstrate like to different medias like Forbes or others they can buy. And later on, some of us try to start up from those. There are 20 different projects. So from there, I realized the only way, what people need for only way to make brain machine interface to be part of this like wearable computer is not like to working on just a better sensor. The only platform can make all of those personal communications in data input better for what I want to do is building AR headset, building a whole platform that with like the better operating system, all of those things together. Then I quickly realized the biggest problem for that is not the chipset, not a better operating system yet. It's the optics that don't work, because when I was looking for a platform on that, there's nothing like optics works. Like it's either very blue or field of view is very small. It's all like noise. So because me and a bunch of friends, we have background in optics display, are very interested in like I have some roommates working on LiDAR projects, so I'm like so I'm very interested in like solving these problems, and I talk with a bunch of researchers, inventors, and other people around me. Every time like seems no one actually want to dig deep into this. They all said if Microsoft can do it, why they want to do it? Why they even try? And so basically, like from there, I spent several years myself working with like some team members, digging into every single components, every single possible method of prototyping using like alcohols, using DLP using like lasers, using like OLEDs, eventually on micro LEDs and other type of displays, and like different components, spatial light modulators, and like from optics display to the pipeline, we try to pick every single components on and how do we upgrade those and understanding the manufacturer line from there. So that's how Kura gets started. And I have more and more peoples. Some of them coming from a lot of them coming from a nanofabrication or semiconductor background. Like more than half of our team member right now having a background that have like chip out in the past. I've been working with large chip manufacturers, and so some of them coming from academia, the people who help along the way, and some of them coming from like management supply chain background. So that's how Kura got slowly formed, and like we are more like a research project, I would say, in the first 1.5 year or two, but only until like 2 years ago, and like we started building more like when like we're doing fundraising, where like we have a more coherent plan of like deliverables, like roadmap by roadmaps, and so I always want to work on consumer AR, but we shift our marketing back and forth due to the current market. So right now we're of hybrid of like enterprise and a partial of the consumer who more focus on the professional or design use case, present use case. So we're like Kura, I feel like we're at the right now where we closed our seed round, like all the seed round by the end of last year. So we raised a new round last year, and soon we're moving into our Series A. So we're at the like initial of equity funding right now.
That's cool. Compliment.
Thanks.
And so let's talk about the product. So the first product that is on your website is the Kura Gallium. So can you describe its specifications, its design, how it works, these kind of things?
Yeah. So the Kura Gallium, we're talking about the production version because we also have developer kit set earlier than production version. So so the spec, including the field of view, is 150-degree diagonal, and it's 110 to 120 in the horizontal directions, and like 80 to 90 for the vertical directions. And so the we have two eye. It's not fully 100% overlap. It's have a like a high percentage of overlap, like higher than 75%. So and so let me see what other things are there. That's the field of view. We have resolution. It can do 8K with foveation. The display optics hardware itself can do 8K with no foveation. But as we know, the computing power. So even when we have the best Qualcomm Snapdragons right now for using, they are not able to fully power full 8K at a good frame rate, like 120 frames per second to our 8K with no like downgrade of resolution at your peripheral view is not doable. So we support foveation, that we create our own foveation algorithm and like frame predictions. So and when you tether to the PC, we're able to support 4K if your processing power. Like some of our clients having like this large of like server side, they're going to do all the rendering on that, so they can do that for the specific use case. And so it have the like the frame rate like we're going for in like over 100 frames per second, and but it does adjust depending on your net worth, like bandwidth. So if you're doing streaming with someone who is remote, we will blurring some of the background, like doing like downsampling. So we run various compression algorithm on actually on the hardware itself, and also which on the SDK level. So and also on the application level. So it working with Unity game engine, and people can write Plan C SDK. All the API have a Plan C version. They can easily embed into all different language. I also have C# and like other like Unreal coming soon. And the PC version, we by default people working with Windows, as most of enterprise clients and a game developer using Windows by default. And we also try our best to support like Linux and also Android. So the computing pack is running like on Android. So it will have a head position tracking 6-degree freedom, gesture recognitions, and like input controllers, more than one input controllers for different scenarios. And not all input controller will make bias. Some of those were certified with or paired with existing controller partners to working with this device. So we also have eye tracking. So foveation will be done in pair with eye tracking. And eye tracking can also generating the user attention data. So basically you can click, long term will help you can use your controllers with your eye to help selecting things better. And what other things? Let me see what they haven't covered. Brightness. So we have a very high brightness, and the image source output like up to 3 million nits. And when the light got to your eye, still like thousands nits. But we're changing those the brightness, tweaking those with ambient light sensors. It won't be too bright when you are in like a dark room. So it's actually so with top brightness we can do at your eye and constant level is thousands times brighter than existing AR's average brightness. So what other things there? I think those are most of the features. Yeah.
The depth perception.
Also. Oh yes, I mentioned there's have a 6-degree freedom head tracking. So you'll have a full depth perception. So we have head tracking. So there is a so structured light camera on that. And there also have camera light looking into your ambience. So those data, they will access to those to improve computer vision, and those are also camera stream that developers could get access to those in some different ways. Yeah.
Wow, lots of things. And I've seen in the current design that you have in the website is very light, also has a cable coming outside. So I think as you talk about Windows, Android, Linux, so it's an all-in-two device. There is, I guess, a USB-C cable that goes outside of the glasses, is it?
Yeah. So that is USB-C. Yeah.
Okay, and do you think that the final device, because you talk about lots of hardware, eye tracking, cool displays, cameras, etc., etc. Do you think that you can reach the super thin form factor that you have on your website?
Yeah, so the final those features actually don't really take much space, fortunately, because camera you can make them to be very small, those is like PCB level, so like same for the eye tracking modules. They are like those are having right now is like 1 nanometer camera diameters. You can get those, and 1 millimeter. So those are very small, so those are just PCB remaking, and so the form factor will be close to the one on our website. We did more ergonomic studies in the past 1 year. Like we test different head. So we actually found we actually changed our industrial design recently a little bit. We add a headband in the end, so when people bend down, it won't fall off. Just like so, because one thing we tried on like Unreal type of like glass is if you bend down, even that's lightweight, even that's under 100 grams, like you bend down like this, if it's at a glass form factor, it sometimes slides off. So we want to like 100% avoiding that and avoiding putting any weight on people's nose. So we actually put a thin headband, but the overall form factor is close to what I showed on our website. The hardware parts is in total like less than 100 grams. Is around 80 to the goal is towards 80, but like it won't exceeding 100. From like all the components estimation and design right now.
Wow.
So the rest is in the pack. Yeah.
So since I'm a techie guy, I want to go a bit deeper in the technical details, and I'm sure that you'll be happy about it. So you talk about you have this large field of view that, as you said, is much bigger than the one that Microsoft and all the others are obtaining. So how is it possible? In your website, you talk about structured geometric waveguides. So what is this magic? How does it work?
Yeah. So okay, let me. So that structured geometric waveguide is just part of the thing. So there's a couple things that enable us to do that together. There is our customized image source. So we designed a customized micro LED image source in customized form factor, shape, and distributions. And we designed our customized display driver ASIC, which is a mixed signal between both analog and digital driver. So we designed that. That is bound together with the image source. And there's also projection optics, which we call projection optics for anything before that light coming to the eyepiece. So that including optics, optomechanical structures, and different like subcomponents there. So all of those together enable this whole thing, not just what's in front of your eye, not just the eyepiece, which we call the structure. So the structure we've got is actually just a name we named. And so it's not anything, you will go search for that, especially if you translate that to Chinese. Like when we name it, we didn't translate to Chinese. When we translate to Chinese, actually the name exists. And like so after like when people found things like, okay, that's not what we are. So basically we optimize those patterns on the different layers of the eyepiece that is getting the highest transparency at the same time getting the best uniformity for both the light that passing through from the image source and the light you can see through from your environment. So we run a full customized optimization from our in-house software that we write for that. We didn't find any existing optical software could actually handle that. So that integrated with the existing optical design pipeline to do the final verification. So what eyepiece give you is the good transparency, the good efficiency, and like no ghost image. But majority of the field of view is generated actually before the eyepiece, not inside the eyepiece. Was in like ways from the micro LED all the way for projection optics there. So the only way we can do this is because we design customized chip, we design customized display, we design all the other components and optomechanical structure from semiconductor level. So we have a couple of different chips we're working on tape out this year. That's actually the most challenging part is to fight with the semiconductor timeline. The optics part of this is actually comparably simple and quicker timeline. Like as far as you can do one chip, you can do like 3 to 5 rounds of optics. So
talking about the optics, also I remember some people, since the website there is this picture with all these dots on the display, they told that it seemed like the old LetinAR for LetinAR AR glasses. Is there some similarities between you and them? LetinAR.
Yeah. So it's not any collaborative project between us and them, and we designed that like separately. So their design, our design is completely separate. So we didn't really found because I saw some of their demos before on CES, and that's all I know about them. And so basically, like the patterns on their mirrors are pretty uniform, and there's having so those type of pattern having some uniformity issues in general. So we're able to solving that and getting a way higher flexibilities to the eyepiece that able to generating a better transparency, more uniformity, and make it less visible to people's eye. At the same time, the optimization create a better efficiency because that's one of the optimized factors. So the most of the magic of that is because mostly what I see they do is they just put a panel display on the top, and they put a panel display on the top or have some simple optics. And so one big problem for that method is the brightness and also the field of view. So we are able to increase the field of view like way bigger through like our customized projection optics and solving some other like. Also, like another issue is resolution, because like if we want to do 8K per eye, there's no like even if like you can get someone to potentially make a 8K OLED is going to be very dim. Like 8K full color micro LED is probably not going to exist in the next 5 years, and So basically, like literally the physical panel, I can see like 3 color in one with a very small form factor, 2 megapixel pitch is not going to exist in next few years in any company. So like, but we're able to jumping through that problem by using current manufacturable micro LED to do 8K right now using today's existing. So that is mostly the creative parts coming out on the display side. And there's also like the IPs is highly optimized compared with what, but our IPs is only usable with our optical engine. If you take our IPs, try to put a different display engine on top of that, it won't work because we optimize it towards like single digit of micron accuracy. So have to be fully aligned. So we're also building the alignment and assembly process of that.
Cool. And I would like to ask you, there are some other cool tech details that I want to talk about is the device you're making. So my audience is usually also made by people that are technical like me. So if you have some other curiosities, technical details that you want to share about how you're making this cool optics and tracking and everything.
Mm-hmm. Oh, so you mean like more details?
Yeah, if you have some more details about technical details about your glasses, about how you're creating all these amazing features that you have.
Let me see. There is many different details. Let me see what I can talk about. So how we do the process? Yeah, so when we choose the image source, we compare with like so as some of the previous posts and some of people know me and knows that I used LCOS display. I tested with like lasers. I tested with DLP. Like just for LCOS, we test many like so we're doing very intensive supply chain. So we're not one of the company who we don't like to use supply chain. The things we used in my past job, I keep using it. So whenever we choose one single components, even we choose manufacturers, toolings, we did a full supply chain like brute force. That is very important for us because we had the latest unbiased information from the industry, from other like suppliers. So then we choose micro LED because it is way higher efficient and compared with macro LED, and it's way higher brightness compared with them. So and also it don't suffering from this LCOS having this problem of color breakdown because people have time sequential LCOS RGB are in different times, and when people rotate their head like me and one of my housemates at that time like we have something like a kaleidoscope, like they're shining like RGB LCOS, like just a basic simulated LCOS on people's heads, like people moving their head to see how many people can see the color breakdown when they move their head. The answer is not pleasant, and so we share those data honestly back to some of the LCOS companies, and so like that. So also we have the same prototype we built. Like it's actually one of the prototype I post on a website with a demo with a demo there. We switched between OLED LCOS and micro LED image source on the same prototypes. And fortunately, they actually works. And so with OLED and LED is way better contrast ratio compared with LCOS. So LCOS have its own merit for projections or other different use, and like as spatial light modulator is very, very useful. And can do solid state beam steering. So that's why we move out from that. And for like what's like DLP, TI mostly holding all the patent. We didn't see too much new product coming out per years, and it's quite expensive compared with other price. So we use that, although we have good contrast ratio, we didn't really dig too deep into that, giving like the whole IP landscape around there and price point. So there was like OLED, okay, because the brightness is not that good. So this way, everything we want to test out for frame rate, we build prototypes for that. And like we test with all of us on our eye, and we not only just listen to like how people experienced what did you use at their last job, we keep using that. We don't do that. And so that's how we are able to make decisions quicker. So other things, we did a lot of things in our lab or in our garage. Like we assemble all our initial prototypes down here. We have like some scan electron microscope. We're right now building a electron beam coding machine here. And I'm really interested in getting a diamond turning machine here as well. But I'm not sure if the place where and could power that thing. So we're going to have a shop soon. So we do a lot of we have oral deeping microscope to look at small structures. And so basically all different we can etch our own optics here using laser, femtosecond, nanosecond laser down here. And so we do our own cold coding of sputtering. So different process. So we did a lot of things very hands-on. So if there are people who are hands-on engineer who are interested in finding a job, I know.
Yeah, I think everyone would like to work on this.
Yeah. So that's why one thing was when we so we really like hands-on design engineers to we don't really look how much paper they publish in the past in a relevant field. We look at how dirty they can get their hands on and on different learning new things.
That's the best attitude, I think. And so I last year you invited me in Twitter to come to see you at CES, but I'm in Italy. It was a bit distant for me to see your prototype. I missed that opportunity. This year there has been the COVID, but last year you told that at this CES you should showcase something similar to what you're promising on your website. So what is the current state of the project now? Are you already there with the glasses similar to the one on the website? Have you some prototypes? Where are we now?
Yeah. So we have early alpha units and internal demos of different iterations. So what we build, what we're building here, mostly as an engineering process, we're moving along directly towards the production. So there's a couple of threads. There is we build demo units or developer kit that we called. That is close to performance on the website, but not in full production version with so there's some plastic with 3D print on that. And so those are for the early clients that we have, including corporate clients and even some government clients. And so we showcase some of those to them by milestones, and we'll eventually ship those to them batch by batch. We only make a few on one batch, and then we make a dozen afterwards. So we have a few of those, and we actually light them up working in last month, and we haven't shipping those fully to them. We're in the final fine tweaking of the assembly process. And so those are the initially early available units, I would say, for shipping. Hopefully we can do that in the coming month or two. So basically all the components is here. We just need to assemble a lab back to place. So for a better, so we actually some good news we have. We are actually moving faster than expecting to tooling to the optics. We're making a mold for the optics too. We get a very good price code for that. We can make thousands of those from less than 20K. So I get a pretty good count for the initial tooling optics. So we're working on that. And the initial product that is fall mass production that are shipping will be towards late this year. But before that, we're shipping the early dev kits batch by batch. And so the fall mass production units will be from towards end of this year to next year for the whole year. The production volume should be ramping up very fast because everything was designed with hundreds of thousands or millions units in mind. We don't design with right now the early dev kits units are already design is already done last year. We're no longer working. We mostly just assemble things. And if you see there's manufacturer coding errors, we can recode the thing. So that is already done, but in assembling process and inspections, we put on the SDK, assemble that. But the majority of team effort is on the fall production unit right now.
Wow. Since you're talking about the time, so when we can expect the device, what is the price? Because on the website you ask for a reservation of $111, $111, and
Also, the other day I was looking on Tesla's website. Cybertruck you only to put $100. I'm like,
so
yeah.
what is the expected price for people who want to buy it? If you can disclose it, of course.
Yeah. So the price is not secret. The price for the headset is $1,500 for initial production unit. So with a cost of like close to $500 or so. Once the quantity goes higher, the cost we're driving that lower to like close to $300. So on top of that, there is software SDK with a for enterprise customers who want to fall capable of a computer vision SDK or telepresent color visualization app monthly use for enterprise, they can load their 3D content that come with around another $100. But we also have those are free of SDK charge that developers can develop their own. And we can also generate new SDK functions on people's demand by piping the new SDK functions. For example, if someone want us to do like object recognitions, eye tracking for their users know what they're looking at, and what others like to see if you fall asleep when they're driving. Those functions we can do as just one-off function launched towards our SDK with a specific price, like with a SaaS model, either developing by us or developing by a third party.
That's very interesting. But another thing that in this year, in this like 2 years, there's been some talking about your company and the AR communities and the AR communities. And on one side, everyone is very excited about what you're doing. On the other side, people are quite skeptical that a little startup can do better than Microsoft, Magic Leap, whatever, with less money, less people. So how do you answer to these people? Why do you think that you can do it?
I never thought I could do that. So let me see. So the reason I think because there are many companies with large money who want to do AR, even just in the past 1 decade. But the fact is nothing works. So,
Yes.
the fact is there is a lot of patent files. There's like hundreds, no less than thousands patents filed on the core IPs. Same IP got filed many times all different places. So the fact is, like, if I'm a researcher, just say I want to AR has that cool works, nothing works right now. And so I think the fundamental thing was there needs to be some acceleration there to like a startup actually works better in situation like this, just like the early semiconductor industry. Like, so the innovations happens in like team level, engineering team level. Once we know the goal cycle. So it's not really like the decision is very, very critical at the AR company, because if you choose a different optical method, if you choose a different display, you can spend 12 months on a thing. Sometimes that could be dumped and end. And some companies like, okay, we already spent $1 billion, let's just now dump it. And so when new things coming out, especially at large company, because the people who lead the technical side of that is normally not the original founder of the company. They are recruited as a VP, recruited as a lead engineers of that project. So if they propose something like what Kura did, like no one had ever done, same thing. That's what our supplier told us. Like, we just have a call with one of our core suppliers. They told us, like, actually, let me tell you a secret. I cannot break an NDA, but I'll tell you, I didn't see anyone did anything close to what you guys did from other large clients. So what happens is when hire engineer who have small equity in the company, who got good pays for lead those projects, it's more risk for them to follow, like, to design something completely new and then having some unexpected errors in the end, because they may not be able to handle so much resources at the company. Then for them to follow a quick, like, secure path that they know would likely to work to some performance, it may not be that good. So I feel that's what I learned in the most large company type of committee-based decision making. I think that's the reason, like, one of the reason that it's very hard to have that level system innovation in a quick time in a large company. Even sometimes when I was working with like Kura's team members, like we have to be very driven on the like fact driven, practical driven. Now like, oh, no one have done this, like it's too hard. So like to us, because like me and my team members, like we be responsible for everything. If things break, like we can make decisions. If things break, we go fix that. If we run out of money, we go raise more money. so that's how our decision making goes through. Like we have a very performance engineering driven decisions. That's one thing. Second is this is a very systematic level projects, and sometimes one person, one expert in optics, one expert in like micro LED pixels. If they don't collaborate with the optical team, they don't collaborate with the algorithm software engineer who can write their own ray tracer like from scratch. Those are very different fields. Like one person you'll find in Disney, another person you'll find in like Corning or Kodak. And if they don't bring those people very, very close, fully understand each other with no bias they cannot come with this system level, because every disadvantage on the micro LED, we had to compensate in the optics. Everything in the optics, we're compensating in some other mechanical structure, and everything in the existing optical software had to compensate in, like you cannot bring I'll claim there's no one person know all those fields I ever met in the field. And so including everyone in Kura, but we collaborating a very close form factor, and like each person try to learn a part of the other field, and so being very open for that is very important.
Okay, and so you talked about current customers, partners of your glasses. I think that, as you said, they are in the enterprise market because it's the first one that can invest in this kind of devices. Can you tell us, not the names, of course, but more or less the sectors in which your glasses or your application in which your glasses are being used?
Oh yeah, so the application. So we're very focused on initially we're starting as enterprise. We're very focused on enterprise last year as we talk to different people, and towards the end of last year, early this year, probably some accelerations through the pandemic, is we get a huge amount of interest from two factors. One is actually consumer. Telepresence streaming, like telepresence, because people are all at home, like telepresence streaming became like the new AI or something. So that became a very hot thing. People tried all the way to telepresence streaming, selling things, try to show their work. So Kura turned out to be one like the best platform to do telepresence streaming, collaborative working. People can working from home and remote collaboration. I can show this on my table to people. So that is one of the core use case focused on telepresence streaming and collaborative remote working. And that can also be spread out more to involving 3D design. 3D design showcase can train people remotely. So basically we're making an enterprise/consumer AR headset that anyone who is in that factor is we providing SDK to supporting them. There's also people like in entertainment, in like medical and in like automotive, and even like military training, and like where people just want to buy this to do Zoom or Skype. So we're also supporting that.
What's the feedback of the first users of your prototype glasses?
Sorry?
What's the feedback that these first customers are giving you about your device?
Oh yeah, so we haven't started fully ship the initial alpha yet, but we have previous prototypes. So we did we did different demonstrations for POCs with different. They already buy the dev kits and later units after they try that. That's what we get. So we sold out all the dev kits. We originally only planned to make like 10 or 20, and people are booking like hundreds of units right now just for the dev kits. And so we have to cut off the order because the more dev kits we're making, we have to potentially delay our production timeline because of our small team. And so we have pretty positive feedback so far. And for people either try demos and try to like our partially finished alpha dev kits. And so because if they don't want it, why so we're sold out after they try that. And let me see. That's what we are like. So people also have like different like questions, like is it going to be comfortable and things like, because some other dev kits is like not like with the right headband as we will be eventually have. So we put more effort on ergonomic study. We actually hire some really good designer and like test with many different head. We spend months on those.
So after all this talking about your glasses, I will try to ask you if I can see something about them now.
So right exactly this moment will be a little bit hard because so we're in a moving stage where it's like we haven't really unpacked most of the lamp. But so we will do some like basically we'll be starting shipping those out to people, like to the initial like core strategic partners, and like including some of the world's largest computer companies, software companies, and film production companies from like a month to two, and in batch by batch from now. So once we starting doing initial unit shipping, and we would mind we'll do live streaming demos and unit, and so we are very tight on number of units right now because those are like one-off. We order like 5 in one batch and another 10, and we assemble those all in-house. But we can definitely do a live streaming, and we have also planned to not say I will 100% do that. We have plans to like we have investors and other like core like partners in different part of the world. We have planned to potentially ship some of those out just from California for them to have some location to do some testing. It may not be fully publicly accessible, but like we'll have like invited guests and people who come in try. The majority reason for that because those are early dev kits. If you give to people, they may break that. So those are not production unit. Yeah.
Cool. So it's okay about the glasses. I think I asked you enough questions. Now let me just ask you something more generic, like what's your forecast for the next 5 years in AR? So it's a very common question. What do you expect to happen from now to 2025?
Yes, from now 2025, what I believe is I think along with basically Kura launching our first product, and for us, we'll get into enterprise and eventually consumer market or before 2025. And for other AR companies, I think the whole need is similar. It starts as enterprise, getting into more consumer. There could be different AR headsets other company got launched. Some of this could be more like ODG or Google Glass is more for information display. So like they have like a small field of view, but they show notification. That could be a different type of product with different use cases for fitness, other things. And I do believe the design we have could be one of the pretty mainstream design, and to ramp out the production, and like we could partner with some large companies like large cell phone computer companies with the cell phone supply chain to ramp up the production faster and cheaper. And in next 5 years, I think the software ecosystem will be way more built. Like, so AR is not a place that people just build apps right now. The AR is a place we need more tools besides just apps. So like when application developer in VR, they build things, they just call different functions in Unity. But in things in AR, even if just for a simple surface detection, surface smoothing, I take months to make it perfect right now. So if I want to place a cuff, if I want to detect my table surface, like constant do object recognition in different light conditions. But fortunately, thanks to our AI community, there is a lot of people, companies who have resource, who have like ability to do those. So we want to enable those community to build SDK for build application for AR, not only application but tools for AR that eventually enable application builder don't have to go to rewrite their algorithm for eye tracking every single times for different functions. Like just for eye tracking, there's many things you can track. There's like attentions, like other stuff. So I think 2025 is definitely the year of consumer AR, but there's a lot of work have to be done in like semiconductor, in integrations, in optics, in like tools, in like so just like a lot of work need to be done. I think it's there.
So you talking about the marketing all over the world. You come from China. Now you work in the US. What do you think is the difference between the XR community, XR market, XR ecosystem in China and the US?
I see. Let me see. I come to US when I was in high school. So it's like I'm not too familiar with the local XR community, but like mostly remotely familiar with that. And I think from so since public knowledge, like HEC is one of our investor. And we did got drawn into the HEC ecosystem to know a lot of like we know a few dozen of content developer company, eye tracking company. From that, so let me see. I think in US, there is more fundamental technology, like people working on contact lens, people AR contact like modulation, people who working on like micro LEDs, people who working on like fundamental like optical innovations. In China, there is, I would say, let me see. I see more content development companies and more like company doing tracking, and so more companies who they have advantage of moving something from if something is just already ready for production, everything's set, they can move from there to full mass production like in a few months, really quick, and so really so that's what it because just like I have a call with some of my friends who working at a venture funding company in Beijing just a couple of days ago. It's that like they work like 10 hours and minimal every day. Everyone's in person, and their colleague who is underperformed just disappeared because they move too fast. So that's not even like DJI. DJI was even more crazy than that. So that will cause big ethical issues in like California or like probably like in other countries as well. But that's how majority cities in China, like in people works. But I do see like more fundamental, like in like Europe companies, US companies, more fundamental process development that is true innovations, but it just moved comparably slow. So it's like the more change driven things happens like more often. It doesn't. There are also like very innovative things happening in China, but more often in United States and other like Europe companies, and so and like so but China is like they have this huge driven like I was also talking with my friend there. They mentioned like in China we don't have secrets. They'll tell you anything. We don't have IP because why? Because even if you have IP, if you don't move fast enough, people will copy you. They understand that. They don't understand if they have IP. Like if you don't move fast enough, so they move fast as they can. Just like so I think like that's the comparison. But like if that core IP is not fully figured out. Like so, and also another thing is I see US have a like for example, giving that so like if we have a PCB board, we want to shrinking that down a camera board, we definitely do it in China. We find the ODM just like gave the spec, we're working with them, like they can make the board smaller, like very fast in a few days. And like a couple iterations, like very soon. Like same for like some of the optical or mechanical components, but for design, if you want to do ergonomic study design, like UI design, color design, application design, that part seems not fully wired in most of the Chinese software development because we don't really care too much about user experience, not that much as like not like Apple level. So they're faster for doing electronics, but US is better on like human art design. So that's why we do all the ergonomic study and design here. But like we like try to do as much as outsourcing of circuit board, PCB, and like system integrations, firmware integrations there.
Talking about another debate that is ongoing in the communities, this has also been the year of the Black Lives Matter. There is also this talk about inclusion and women in XR, about different people from different backgrounds working together. So what do you think is the current status of the XR ecosystem nowadays about this? So have you ever had any problems regarding inclusion? Have you any suggestions for us all about this?
Yeah. Let me see. I think cutting having people in different backgrounds working together on XR is very, very important. As you'll see, it's like it takes a whole world to make a cell phone supply chain works. Okay. So I think AR is the same. AR supply chain is like probably as broad as cell phone, or even broader, will be even broader. And have to have the like Europe semiconductors together community like with like US integrations and designs and like Chinese manufacturers, and so people are trying to find cheaper place to open up new office, able to hire people. So it's very important to having different skills type of people working together and being open and like respect each other, and like respect timelines and contract. So and the AR use case is also, especially AR is like during pandemics, like sometimes I heard I see my friends post, I feel I'm depressed because I haven't gone outdoor for like 100 days. So sometimes I have the same feel too. And like when can I travel next time? It's like when can I like we have a trip to Seattle to demo this device. It got canceled because the company is really afraid of COVID. And like even if I go there, I text my friend, hey, I'm in Seattle, do you want to meet? Like no, I don't want to meet you right now. And like so basically like AR have a very worldwide use case. What like some of very top use cases telepresent from like California to like Shanghai. It's like you can have a person holding your camera, you can have like robot holding your camera. Because AR is the best tool for like make the culture understanding more close, make people working just like not only for like for tourism, for like conferences, for business meetings, for showcase, or just for entertainment for 10 minutes. So AR is a tool that enable this. So that's one thing. The second thing is, I think for my personal perspective, I think it actually gave me more inspiring of the use case, because I understand how people in China lives, how people here lives, and what's pro and cons. Like I can go to deal with some Chinese clients. So just as a Chinese, I don't get tourist price. So I will switch back to Mandarin, like talk with them. So I can literally talking with like factories in China, like just they will think I'm in China, and so that actually help us on like fundraising, business development, and manufacture internationally. And as for women in XR, I think like there is. Let me see. There are some biased people towards women, not only in XR, just in general technology, especially like the hard tech fields, like semiconductor, like heavy equipments, and to very always emphasize that sometimes actually make people feel. Well, every time they think of me, it's like there's women in XR is not what I'm working on. So I haven't been talking too much about. I don't really speak things too much just based on my gender, but I do what I want to do. But if I feel people treating me differently because of my gender, I'll call that out. I'll say like, why you don't look at my ideas? Like I'm not talking about my gender right now. I'm talking about like these ideas that is work. How do you come? How like is your calculation actually better than mine? And I think the same thing exists not only in genders but like in age. So even in same gender, like someone 30 years more experience, sometimes people have the same pressure. But just like we try to keep as much as fact driven as like a practical point, not like because you publish 30 papers, so whatever the person says is correct. So this is what we keep inside Kura when we choose the suppliers as well.
Wow. And speaking some final, a bit more personal question. The first one is, what are one or two lessons that you've learned in these years of hard work in AR, doing your own venture, working a lot and becoming successful? So what are the lessons that you've learned in these years that you want to share with people that want to become like you?
Let me see. So let me see. You mean specifically this year or like overall?
No, overall, in your life, your latest life in being an entrepreneur and a technical person, everything. So some personal lessons that you've learned I want to share with you.
Okay, let me see. There are a few things. Is one is like finding inspirations is very important for me. Like I identify people I look up to, like in both technical, like just like in like analog design, identify who is very good at analog design, and like follow them, like their work, follow projects. Like entrepreneurs who are good entrepreneurs. If I'm bad at like fundraising, like not like I'm getting better at fundraising right now, but initially when we like because we raised 7 million like last year, but like when we start Kura, I'm like first year I'm very bad at fundraising. So I look at my friends who is technical founders who raised millions of dollars, who can run their companies, launch products, like what they did differently. So it's finding the inspirations, not dragging down because by the people who are not inspiring you. For like, we'll give an example. Sometimes you can have a best analog engineer, but the person try to give you fundraising advice. You need to learn to say no. And so you can also have a software engineer who try to tell you how to do hardware. This could be world's best software engineer, but he's trying to tell you how to do hardware. So like you have to stop there. But you find the people who you identify on your own as the best hardware engineer on the field. You use those people as your role model or your team's role model to as a criteria, as a like baseline, or even place you have to reach to. So that is very important for me. That's basically how I learn new things. So like even like when I'm looking for how companies scale up, I look for those founders who are very good at scale up their company from very small to big, from production, and how they do differently. They may not be the best engineer they may not be the best public speaker person but they're very good at scale company, how they do especially. A lot of time I reach out to them. Sometimes the guys have to be advisors or like friends. So that's one thing. Second thing is like developing your own technical skills is very important. If it's one thing important for women in engineering, not only like XR, is sometimes you got dragged around by our parents. Like my mom told me to learn business, like, okay, fuck that off. So my mom really tried to make me not learn engineering in school. Both my parents are engineer. They think I should try to be a Wall Street person. And before, like if you want to start a company when you're 20s, you only have a few years to build your technical skills in your college or even after college. Like if you want to start a company at an early age, it's very important in that few years, even before, during, or after college, or during your work, you keep building your technical skills. Not just like you can read a journal, but like how fast can you code? Can you build your own operating system? Is like, can you design your own board? Like can you manufacture your own board? Can you use optical design softwares? So like build your fundamental skills with taking very challenging projects and lead those projects, and not just manage those projects, but actually do all the works. And that is very important. Like follow project to the end, take responsibility, because only the people who follow project to the end can see all the problems. So that is very important to do. Like electrical computer engineering majors, like, so I recommend like analog design and like IC design engineers, like major is very important. There are things like app development you can learn even out from college, but like there are some majors you just need a block of time. You need like weeks or months of time. You can focus on that. So that is very important. And also like timing, be sensitive about timing is very important. Is like in starting a company, it only matters if the thing come in right in time. Like if you just launch something like after everyone launch iPhone, you try to launch an iPhone, it's not going to work. So it's like try to manage the timeline, supply chain to be in place is very important for Kura. That's mostly what keep us busy. Sometimes like people told me like, if you think your glass is too good, why not file all the patent, don't work on the product, wait for a year, let's sell the company. Like, no, that's not what we're going for. So I want to see my product being used by people, and like, so those are mostly the overall advice. Another thing is like working hard really works. And so like, I never believe in this thing that people say work smart, don't work hard. You need to also work smart, but if you don't work hard, like not any smart can save you. And so like the thing is like there are different industries that could work if all I want is to exit on Kura, file the patent, and like don't want to launch my own product. But like if you want to build like potentially IPO-able company that with batch of your own product with your own customers and see how people use it, no matter how smart the person is, they need to work really, really hard. And they need to be able to motivate the whole team to working as hard. Maybe not as hard as founder, but like as possibly as hard, like structure a team well. So that's something like another skill I need to learn over starting up Kura. Initially, I just manage myself. Now, like we have a team of like 24 people. Yeah.
Yeah, very interesting lessons. And since I myself like a lot what I do and I work very hard, the problem is that sometimes we work too much and it's difficult to find the time for something else. So I want to ask you if you find the time sometimes for yourself and what you like to do outside the work.
Yeah, there's a lot of things. So just talking about technical skills, I want to be a really good analog designer for like analog electronics designer, which I'm not right now because I started Kura when I was in digital. I didn't got a chance to move more into analog. So I really want to spend months to make and now just like high frequency like oscilloscope like function generator myself, just like fundamental analog, because I think that benefit. We're designing a mixed signal IC right now, but I don't need the design, I need the architecture because I'm not because I don't have enough analog experience before I start Kura. So that's one thing, and I want to get more into nanofabrications. I want to like go into university fabs and run all those machines and calibrate those and see. So those are immediately two things. Those are not directly contribute to Kura. Like even if I want to start my second company in the future, those will be useful skills. What else I can do? Yeah, I want to see what is more happening in this couple of years in China. And like the pandemic giving is really hard to travel, but like it's a very large market there. I want to see more about like what product people like to use. I want to see like telepresence streaming happens between the two places. Yeah.
Okay, amazing. So my last question, it is the same for everyone. Is there anything else, whatever you want, that you want to say to my readers and my viewers?
Let me see to the viewers. Let's see. So a couple of things. Our audience. So a couple of things. What I say to the okay, couple of things. We are launching the Kura headset this year in like for dev kits. If you need alpha dev kits, the pre-production units, we don't sell those directly on the website. So if you want those, reach out to me. And I think there's an email left on the website for that. Reach out to like sales and or me. Like if you are large companies like or individual who want to get access to those. And we have very limited version units of those. And so if you want to see a demo and like if you have your good use case for that, feel free to reach out to us. And in the coming few months, we're setting up demos in different places. And like we are like Kura is in, like right now we just moved to San Mateo. We're putting alpha spec together. Once we get together, we're starting doing some demo and tours. COVID protection needed, and so that is for the product and the mass production product. If you have questions when they buy it on the website, when are they going to ship? The mass production units shipping towards end of this year. Like the majority units will be next year, so. If you have, we're looking for like let me see, we're hiring. So we're hiring. We closed our last round of funding towards the end of last year, so we are hiring for multiple engineering roles, including like system software engineer, application software engineer, optical engineer, analog and digital chip designers, optomechanical engineers, operation persons. So a couple of different roles. And if you're interested, like, and we're welcoming like full-time intern or like other contributors in different ways. We also have other like demo exhibition, like demo scenario we're building. Some of those involve different robots, some of those involving making different apps. So those don't have to be like Kura. If you could, those could be partner with some kind of development shops or people who are interested about the field. We can get your hand early access to the headset if you are starting those program. Like we have developers and Kura Tech, also feel free to email me. Let me see what are other things. Those are mostly it.
Okay.
Yeah. So I can't think of. If there's any, let me see. Soon we'll start raising our next round of funding. If there's any investors or like other people who are interested, and So our existing investors are very, very helpful for our success. Actually, one of our investors just are one of our manufacturer partners. So one of our investors is one of the top manufacturer of optics in the world. They're actually manufacturer for different Magic Leap, Facebook's AR. They do high precision tooling. So and they help us a lot on the process. So we're very welcoming partners that bring us close to the final product faster and better in semiconductor, in OEM, ODM, in trackings, eye trackings, and all different factors. Yeah.
Okay, so hi, thank everyone for watching this interview. Especially thank you, Kelly, for being with me, with all of us watching the video and talking with us about Kura and your amazing things you're doing. So I wish everyone a happy day in VR and have a nice day. Bye bye.
Thank you.